In last video we played with codecs and custom skills to evaluate our platform, theoretical platform, against the maturity model. And I like how the model was able to give an answer, and even more than that, it can explain the assumptions and give a confidence level. And it also outlines the uncertainty, which is good, and it is pretty much everything that I wanted to get from that agent and from that POC. But sometimes it will say something like, I'm about 70% confident in this suggestion. And the recommendation depends heavily on those assumptions and those assumptions. But all of that is impressive, and it made me think. One thing that always bothered me about those language model based agents is that they are fundamentally generative, and they means that if you give the same prompt twice, you may get slightly different reasoning and slightly different assumptions to be the main player. And because of that, sometimes you even will get different recommendations on what to do. And that's often completely fine when you just trying to generate a text or an image. But when you are trying to make security decisions for your data platform, I would like the reasoning process itself to be explicit and inspectable. And if a recommendation would change tomorrow, I want to know why it changed, which assumptions changed, and even more, if nothing changed tomorrow in terms of assumptions, in terms of the state of the system, then the recommendation should stay the same as well. So I want some sort of deterministic approach to this one rather than a generic and generative one. And all of that basically led me to an idea. What if an agent is not like thinking as a single expert? And what if I am talking to a panel of experts instead? In this video, I want to introduce an architecture that I've been thinking about recently. It's not something that I completely built yet, it's just an experiment and a thought exercise that I want to run with you. But I think it is an interesting one, and the idea itself is simple. To separate the language understanding from the decision making. Let language models do what they are incredibly good at, and let the different system handle reasoning under uncertainty. Most modern agents have a similar architecture. User asks a question, the language model reasons about it, maybe calls a few tools, maybe searches some documentation, maybe queries its memory, and then produces an answer. And this works remarkably well. And in fact, every video in this series so far has been relied on that assumption that the LLM is the brain, and everything else supports it. But let's think about how humans make important decisions. Imagine, for example, a medical problem. You don't ask a single doctor if it is not something trivial, and instead you try to ask multiple specialists and for example, a radiologist or a surgeon and a GP and a pathologist and so on. I don't want to name all of those different doctors for this theoretical problem to call, but basically each of those experts, they see the problem differently. Each of those experts, they have a different level of confidence in their own diagnosis, and they all will ask for different sets of evidence to provide, to go and do some different analysis and tests. And eventually all of them, they will discuss their problem between themselves and argue about their own diagnosis and ideas, and eventually the consensus will emerge, hopefully. And we trust that process because disagreement is visible. When doctors do not agree, they cannot really say that, let's try something, let's just cut it open and see what happens. Assumptions of those doctors, they are visible, confidence is visible, and now let's compare that to a traditional agent. Most of the time, we just throw the question as into the black box, and we treat that agent as a single expert. a very knowledgeable expert, a very fast expert, but still only one expert. And that made me wonder, could we build an agent around expert consensus instead of a single one? The first step is to separate two responsibilities. One of them is to understand the language, and second is to make a decision. Today, those are usually handled by the same system, so agents, but in my architecture, they are not. The language model becomes only an interpreter, basically the interface between the user and something else. Its job of that LLM is to understand what the user is asking, extract the relevant evidence. So, for example, if the user provides an architecture diagram, the LLM model will extract the evidence from that model, and then it will convert it into structured information that is digestible and usable by something else, but that second part. Once we have structured evidence, we need to decide which experts should participate and which one of those experts are actually the most knowledgeable in our domain. Because we might have experts like reliability expert, security expert, operations, change management, and so on. And if the question is only about the security, then the security expert probably would have the biggest weight in that question, but the change management, I guess, would be the lowest one. Whereas if it is a regular deployment that doesn't introduce anything new in terms of the security, then the change management and reliability probably would be the most important ones, while the security is just a checkbox, cannot go on. It's something very breaking is introduced. So the next layer is what I call a control mapping. Its only responsibility is to assign correct weights to right persons, right experts for their problem. And now we arrive at the interesting part, the experts themselves. My idea is to represent each expert as a Bayesian network. And why? Because experts shouldn't generate text, experts should just generate those beliefs. And those beliefs should be very deterministic. Expert from the reliability side of things might evaluate the monitoring health, test results, deployment size, or some historical rates, and then produce something like that the deployment success probability is 84%. Then security expert would chime in and evaluate different type of evidence. So, for example, what are the security posture of the system, how it was before, and what changed in terms of the CVEs. And it will produce a different probability of the deployment success from the security point of view. And notice what's happening over here. We no longer generate reasoning, so we can deploy because of blah blah blah. Instead, we are trying to model the uncertainty. Now we have multiple experts, and the question would become, how do we combine them together? This is where the consensus engine will come in, and each expert will contribute an opinion. On top of that, each opinion would have their confidence, and the confidence would be static from the Bayesian network because everything is deterministic from that point of view. And then, on top of that, each expert might carry different weight based on the control mapping from the before. So, for example, for the deployment decision, the reliability expert might matter more than the cost. And for a security review, the opposite might be true. And the consensus engine itself, it will combine those experts' opinion into a final probability for the answer that the user wants to get. Not a yes, not a no, but just a belief with a probability and a weight. And now the language model will come back, but now its role is different. And instead of being the decision maker and the brains of the whole architecture, it becomes the interface. The Bayesian system produces the consensus. The language model after that explains it. And with the retrieval augmented generation, it can also suggest the next steps. So, for example, the expert panel, the Bayesian network, would estimate that there is a 73% chance of successful deployment. And it will also provide that the main point for that uncertainty is service health and the deployment size. After that, the LLM can do the RAG and check what is the recommended action, and it can come up with suggestions like run additional smoke tests or reduce the rollout scope, or maybe to validate all of those monitoring alerts in advance. So that's my whole idea, what I tried to build, and I hope you find it interesting. And let's see in the next video how it will work out, how it will combine everything together. See you soon.